Hello, friends. Today we are going to talk about solving quadratic equations by factoring. So you've been working very hard to practice factoring, learn how to factor. You guys have been doing so much of it, and you have learned so much, and you guys are getting really good at it, and I hope that it's starting to come naturally to you and be easier to do without having to think too awfully hard. But we will continue to practice because the next thing we're doing is continuing to factor, but we're going to take it a step further. So when we have an equation, so far, everything that you have factored has looked like ax squared plus bx plus c, or some version of that. Well, now we're going to have this equal to 0. And now we've put an equal sign in. And if there's an equal sign, that means we can solve for things. So we are going to learn how to solve for x by factoring. If you remember, when we graphed equations, the solutions were the two places where our graph crossed the x-axis. Those are called x-intercepts. And so if our function was y equals ax squared plus bx plus c, how do you calculate an x-intercept? You calculate an x-intercept by setting y equal to 0. So that's what we're doing here. We're going to use factoring to find the x-intercepts or solutions or roots or zeros. Those are all the same thing when we're talking about quadratics. We're going to use factoring to solve them. All right, so these are our steps. You can pause and write them down if you want to real quick, but we're going to use them a lot, so you'll get used to it. But you have to move all terms to one side and set the equation equal to 0. Factor the equation. Set each factor equal to 0 and solve for each x value. And then write your answer as a solution set. And so what that is, these little squiggly things mean that this is a set of numbers. So x equals the set of numbers, blah, blah. And we'll write our answers in those blanks. Okay? So let's just go ahead and dive right in and start practicing. So remember, step number 1 was to move all of our numbers, everything to the left, and have the equation set equal to 0. Well, it's already equal to 0 in this problem, and actually the first few problems that I'm doing don't require you to do step 1. It starts you out with the basics, and we just learn how to factor. We don't have to do the prep work. So, step 2 is to factor the equation. So it's still going to be equal to 0. We don't do anything with this part. But over here, we learned how to factor these things. I don't know, actually, that we've had any practice problems where you didn't have a c value. So we have x squared plus bx plus c. I don't know if we've had that yet. So I'm going to show you if there is no c value, then these terms actually have a factor in common, and that factor is x. So we can factor an x out, and that leaves us with x times x plus 9. So that's what our equation is right now. So once we have it in factored form, we set each factor equal to 0. So this is a factor, and this is a factor. So x equals 0, and x plus 9 equals 0. Then we solve for x. Well, x plus 0 is already solved. We don't have to do anything else. X equals 0, not plus, sorry. But here, we need to subtract 9 from both sides. And that gives us x equals negative 9. So those are our two solutions, but it asks us to write them in a solution set. And so the way that we do that is x equals squiggly bracket. And then you write them from smallest to largest. So we're going to go negative 9 and 0. End squiggly bracket. Okay, so this is your answer, and this is the proper way to write it. Now I want to do a quick explanation as to why we set these factors equal to 0. So let's say that the first factor is big A and the second factor is big B. And these can be x plus little a, x plus little b. Okay, so they can be binomials. That's okay. But at the end of the day, we have the multiplication of two things, correct? Correct. The answer is correct. So we have something that says a times b equals 0, where a and b usually represent binomials, but like in this problem, it was just an x for the a part. Okay, so what happens if a equals 0? 0 times b equals 0. Well, it doesn't matter what in the world we put in for b, anything times 0 equals 0. Okay, so that's why we can set a equal to 0, and that'll give us one of our answers. Well, what happens if we set b equal to 0? Well, then we have a times 0 equals 0. Well, if b is 0, then no matter what a is, we can make it anything in the world, we'll still have 0 on the other side because anything times 0 equals 0. Okay, so that's why we separate the factors and make each one equal to 0. Okay, so x squared minus 4 equals 0. So there's only two terms and there's no b term. So the bx part of ax squared plus bx plus c is missing. So the first thing we have to look for is this a difference of perfect squares? Because we have a difference, that's a subtraction sign, and x squared is a perfect square, and 4 is a perfect square. So that means, yes, we have the difference of perfect squares. So we learned that a squared minus b squared could be factored to a plus b, so here's a and here's b, times a minus b. Okay, so we know how to factor these. So what can I square to get x squared? I can square x. What can I square to get 4? 2. So a is x, so everywhere there's an x, we put an a, or vice versa. And b is 2, so everywhere there's a b, we put a 2. So congratulations, you factored this equation. Now we set each factor equal to 0. And we're going to solve. So subtract 2 from both sides here to get x equals negative 2. Add 2 to both sides and we get x equals positive 2. So the way that we're going to write this is x equals the set negative 2 comma 2. But you can also write this as x equals the set of plus or minus 2. Okay, that's also correct. Okay, so this one is kind of in my view, it's one of the easier types of factoring. A is equal to 1, so we can just go ahead and set up our binomials. We know we're going to have an x here and an x here. And we need something that multiplies to get positive 21 and adds up to get negative 10. So if they multiply to be a positive number, they have to have the same sign, and that sign has to match b. So we're going to have two negative factors. So what two numbers multiply to get 21 and add to get 10? 7 and 3. And double check yourself. Negative 7 times negative 3 is positive 21. Good job. Negative 7 plus negative 3 is negative 10. Good job. We did it right. So then we set each factor equal to 0 and solve for x. And we have x equals 7 and x equals 3, but we have to write that in function notation. Or not function, sorry, in set notation. So 3 comma 7. Let's try another one. So remember, we always check for a greatest common factor first. These are all even coefficients, so we can definitely pull a 2 out of those. So that's going to leave us with x squared minus x minus 12 equals 0. And then we're going to keep factoring. So we get 2 times x minus 4 times x plus 3. And if you need a refresher on factoring, you can go back to our old videos. But negative 4 times positive 3 is negative 12. Negative 4 plus 3 is negative 1. Okay. Now, we have 3 factors in this equation. But, this one does not have an x in it. Okay, if you remember from the first problem that we did, it was x times, let me find it here, I'm sorry. Oh, it factored out to be x times x plus 9. Okay, so we had a coefficient out here of x. Well, here we have a coefficient of 2. If it is a variable, you cannot do this. But ours is not a variable. It's a number. It's a constant, a coefficient. So what we're going to do is divide both sides by 2 and get rid of that 2. And that's just going to give us x minus 4 times x plus 3 equals 0. Now, if this had been 2x out here, you could divide by 2, but you could not get rid of that x because that would be getting rid of a solution. Okay? All right, let's go. So this doesn't have to do with our problem. X minus 4 equals 0, x plus 3 equals 0, and we get x equals positive 4 and x equals negative 3. So x equals the set of negative 3 and positive 4. All right, number 7. We have 3x squared minus 13x minus 30 equals 0. A is not equal to 1, and there are no common factors, so we have to use the x method for this one. So we take 3 times negative 30, we get negative 90 to go in the top, and then b, which is negative 13, goes in the bottom. And we want something that multiplies to get negative 90 and adds to get negative 13. So it has to be a positive and a negative because that's the only way to multiply and get a negative number. And that means that it'll have a difference of 13 instead of a sum. So our factors of 90 are 1 and 90, 2 and 45, 3 and 30, 5 and 18. But those have a difference of 13, so we don't have to go any further. We need it to be a negative 13, so the larger number has to be negative. So there we go. Now we bring down our a term, which is 3x squared. We use this to make a new middle term and the other part of the new middle term. And then we bring down the c value, and that's still all equal to 0. Okay? And then we split this in half and take the greatest common factor from each side. So on the left, it's just x, so we get 3x plus 5. On the right, remember, we always use this sign, so it's negative. 18x and 30 have a greatest common factor of 6. And that leaves us again with 3x plus 5. And I'm going to keep writing that equal to 0 so I don't forget about it. So 3x plus 5 is one of our terms because these are the same. And then x minus 6 is our other term. And those are both equal to 0. So now we split it up and get x minus 6 equals 0 and 3x plus 5 equals 0. Add 6, x equals 6. And then subtract 5 from both sides and we get 3x equals negative 5. Divide both sides by 3 and x equals negative 5/3. So our solution set is x equals the set of negative 5/3 and 6. And one last problem, and this is one, I'm showing you this one in particular because you do have to use step 1. You have to move all terms to one side, okay? So we're going to move everything from the left over, or from the right over to the left. So let's subtract x squared from both sides. So that's going to leave us with x squared because we had 2x squareds and we took away 1. Minus 50 equals negative 1. So then we'll add 1 to both sides and we get x squared minus 49 equals 0. Okay, so now we have a question or an equation that looks just like the stuff we did in the beginning. So this is the difference of two perfect squares. So this is going to factor to, to a plus b times a minus b, equals 0. So a is going to be x and b is going to be 7. X plus 7, x minus 7. So x plus 7 equals 0, x minus 7 equals 0. Subtract 7 from both sides and x will equal negative 7. Add 7 to both sides and x will equal positive 7. So our answer is x equals the set of negative 7 and positive 7, or x equals the set plus or minus 7. All right, that's all for today. Thank you guys for listening.